Today we're going to talk about section 3.1, starting after example 1, key concept rational exponents. Make sure as we go through this video that you're writing things down so that you have them to reference for later. So our key concept, if we let a to the 1/nth power be an nth root of a, and let m be a positive integer, then we are going to have two rules. Our first rule tells us that a to the mnth power can be written as a to the 1 over n to the mth power, which is the same thing as the nth root of a to the m power. Very similarly to this, if we have a to the negative m over n as 1 over a to the mnth power, because when we have a negative exponent, it has to switch sides of the fraction. And so then from here, we're following the same rule as above. So this turns into 1 over a to the 1 over n to the m, which is the same thing as 1 over the nth root of a to the m power. We're now going to use these two rules to help us evaluate example 2. Now let's look at example 2. So if I have 16 to the 3/2 power, I'm going to rewrite this using that same rule that we just talked about as 16 as the square root of 16 to the 3rd, because the denominator was 2, and so this 2 is understood to be there. But remember, it's redundant to put that 2, so we're just going to leave it as the square root of 16 to the 3rd power. And the square root of 16 is 4, so now we have 4 to the 3rd power, and 4 to the 3rd power is 64. The only thing that we want to double check here is what our index was. So if we look right here, we know that our index is 2, which means that n is even, and a is, so we need two real solutions. So we're going to add a plus or minus to all of our work. Plus or minus. Now let's go ahead and let's look at the second example. So the second example, the only difference is it now has a negative exponent. So we're going to rewrite this as 1 over 32 to the positive 3/5. And so now I'm going to keep going. I now have 1 over, and because 5 is in my denominator here, it's going to turn into my index. So I now have the 5th root of 32 to the 3rd power. And the 5th root of 32, if I draw my factor tree, 32 is 8 and 4, 4 and 2, 2, 2, 4 is 2 and 2. So we end up with 1, 2, 3, 4, 5 2's, which makes sense because we're taking the 5th root. And so now we get 2 to the 3rd power, because the 5th root of 32 is equal to 2. And now we end up with 1 over 8, because 2 to the 3rd power is 8. Looking at this, all right, we just want to double check our index. Our index is 5, which means n is odd. And if n is odd, then there's only going to be one real solution. Now let's look at example 4 on the next page. These two equations are very similar to equations that we previously solved in our quadratics unit, except a quadratic has a highest exponent of 2. Now we're going to be looking at exponents that are higher than that. And so our goal is still the same as before. We're going to get the variable, so x to some power alone. So our first step here is we're going to divide both sides by 4. When we divide by 4, we now have x to the 5th equals 32. And so now we have to ask ourselves, what is the opposite of raising something to the fifth power? We have two choices here. All right, our first choice is to take the fifth root of both sides. So I'm taking the fifth root of both sides. When I take the fifth root of x to the fifth, those cancel, leaving me with x, and the fifth root of 32 is 2. Our second option, if we have x to the fifth equals 32, is to raise both sides to the reciprocal power. So the reciprocal of 5 is 1/5. 1/5. And here, we're multiplying our exponents, and 5 times 1/5 is equal to 1, and we end up with x equals 32 to the 1/5 power, which is really the same thing as taking the fifth root of 32, which is 2. So we see that we've gotten the same answer using both methods. Now let's go ahead and let's add an example that's very similar to this. So now we're going to solve 2x to the 2/3. X to the 2/3 is equal to, this needs to be a 32. Let's just cross this out and start over at the bottom. We're adding this example. So if I have 2x to the 2/3 is equal to 32, I'm going to divide by 2 first, and now I end up with x to the 2/3 equals 16. And so I have a couple of choices. My first choice is I can rewrite this as x to the 1/3 squared equals 16. And the opposite of squaring something is square rooting something. So I'm going to square root both sides. So these cancel. So now I have x to the 1/3 is now equal to, and the square root of 16 is 4. And we need the plus or minus because the index was even. And now the opposite of raising something to the 1/3 power is cubing it. So I'm going to cube both sides. Those cancel, and now I get x equals plus or minus 64. I'm now going to show you a very similar way to solve this problem starting from this line right here. So if we take this line and we have x to the 2/3 equals 16. If we raise both sides to the reciprocal power, so the reciprocal of 2/3 is 3/2, then 2/3 times 3/2 will cancel to 1, and I end up with x equals 16 to the 3/2 power. And now I can rewrite this as 16 to the 1/2 to the 3rd power. 16 to the 1/2 is the square root of 16, which is 4, to the 3rd power, which gets us 64. And again, because we square rooted it, we need the plus or minus in our answer. You can solve both ways. I think that my preference would be this one right here, okay? Now let's look at this second example. Again, our goal is the same. Get the parentheses alone. So I'm going to look at this and I see that nothing is being added or multiplied to my parentheses. And so I have two choices. I can take the 4th root of both sides, or I can raise both sides to the 1/4 power. So I'm going to raise both sides to the 1/4 power because that's the reciprocal of 4. So now the 1/4 and the 4 cancel. So now I have x minus 3 equals 21 to the 1/4. Now I have to get x by itself. And in order to get x by itself, I'm going to add 3 to both sides. When I do this, I get x equals 3 plus or minus, because taking the 1/4 power is taking an even root, 21 to the 1/4. And now I can leave this answer just like this. Or I can plug this into my calculator to approximate, and I can type in 21 to the 1/4 power in my calculator. So now we end up with x equals 3 plus or minus, and when we type 21 to the 1/4 power in our calculator, we get a decimal of 2.141, which allows us to add 3 to that and then subtract 3, so we get approximate answers of 5.14 and 0.86. So this right here is our exact answer, this one, and then this is an approximate answer. Typically, I'm only going to ask you for the exact answer.